Dear students, welcome to another lecture in Elements of Machine Design. We were discussing about couplings. Couplings, most commonly they are called shaft couplings because coupling means connecting two parts. It can anything connecting two parts can be called coupling, but when you say specifically shaft coupling, it is used for nothing else but connecting two shafts. They are used in machinery for several purposes. What are those several purposes? To provide for connection of shafts of units that are manufactured separately, such as motor and generator. See, motor is produced separately, and it has a shaft. And a generator may be produced separately. It has its own shaft to provide for connection and disconnections for repairs and alterations. So we need shaft coupling to join. Okay, to provide for misalignment of the shafts or to introduce mechanical flexibility. If any misalignment is there between the axes, then this shaft coupling will take a little bit of misalignment. Okay, and also it may provide a little flexibility. Okay, to reduce transmission of shock loads from one shaft to another. If one shaft in one machine, so many vibrations are coming, shocks are coming when it is working, so that shaft also will be vibrating. So those shocks, those vibrations should be isolated from the other shaft. Okay, in that case, no, you can provide a coupling in the middle, which will which will isolate those shocks. Okay, then to introduce protection again overloads. When any overloads or something come, then the suddenly, because of that, some costly machine elements like shafts and other things should not be damaged. Instead, if a coupling is damaged, uh, or any of the other things which are cheaper, if they are damaged, uh, it acts like a protection. That means much loss is avoided, little loss only will suffer. It should have no projecting parts. Projecting parts also should not be there. Okay, so next, requirement of a good shaft coupling. Okay, if you say this shaft coupling is good, what should it should have? It should be easy to assemble and disassemble, to connect or disconnect. And that means it should not be too tedious. Specialized spanners are needed and such things. If you do, then it is not counted as a good shaft coupling. It should be easy for connecting and disconnecting. It should transmit full power from one shaft to the other shaft without any losses. You see, see, if the motor shaft is rotating, the power that is there in that motor shaft should completely be transferred to the machine shaft. You see, without any losses. The losses in the couplings should not be there. There may be a little loss, but it should be least. Then a shaft coupling is considered good. It should hold the shafts in perfect alignment. You see, this coupling should not induce any kind of misalignment or anything. It should, okay, if it is designed to bear misalignment, should be able to bear, but on itself it should not cause any misalignment. Then it should produce transmission of, should reduce shock loads from one shaft to another. I told you it should isolate the shocks, and it should have no projecting parts. Okay, the why, if projecting parts are there, what happens? Say, if nuts bolts are projecting suddenly, if we go close, see, somebody's dupatta or somebody's full sleeves, they may be, they might be pulled, with that, and a person may go into the machine, and accident will take place. See, that should be avoided. That is the reason why the protected flanged coupling is used, because flanges have nuts bolts. and that rotating at high speed, and if you come anywhere close, even if you put a hand, it may with hit you with so much force, a wound will be created, or some flying thing. That's why in the companies you are not allowed to wear full sleeves, or any loose parts of the garments. It is avoided. You should not wear it. Okay, when we are talking about the types of shaft couplings, there are two types. We have already seen rigid coupling and flexible coupling. Rigid coupling means it is used to connect two shafts which are perfectly aligned. So when there is no misalignment, this is used. And the types are sleeve coupling, or which is also called as muff coupling, and clamp or split muff coupling, or compression coupling, and flanged coupling. Okay, these are the rigid couplings. And when you talk about the flexible coupling, this is this type of coupling is used to connect two shafts which have lateral or angular misalignment. Okay, both lateral angular misalignment, or singly lateral and singly angular misalignment also. Type of flexible couplings, some of the example, not types, examples of flexible couplings can be bush to pin type flanged coupling. This is also flanged coupling only. Word flange also can add here. See, universal coupling, which is also called as Hooks joint or something, Hooks coupling. Then old M coupling. These are some of the examples of the flexible coupling. A sleeve or muff coupling is shown in the figure. Uh, yeah, there is one shaft this side, another shaft this side, and these both are joined together, and a muff or sleeve. This is inserted from once. It is at the joint, and then this dotted line shows the keyway, and this is the key. This is the jib-headed key. It is inserted, and it is going throughout from this side to that side. This can be called. This is shown in half section. Okay, here shaft is broken, shown broken. Actually, no, in machine design, what you should do, it is in this shape like S or something. Okay, so here hatching is on this side, means the other side hatching should be on the other side. Nowadays, no, this proof reading they are not doing properly. That's why these mistakes come. If this is this side, the hatching should be on the other side. That is how machine design, machine drawing we do. Okay, anyway, and this total length from here to here of this is called as L. They have shown here, actually no. You see, maybe initially that was there and they moved it, and only the dimension is not moved. It should have been from here to here is length. Okay, then d, small d is the diameter of the shaft, and capital D is the diameter of the sleeve. The inside diameter will be the diameter of the shaft only. Okay, we want to talk about this coupling. It is the simplest of type of rigid coupling. It is made up of cast iron. Okay, cast iron, normally all these things, no. Uh, okay, made up of cast iron. It is easy to cast. It consists of hollow cylinder whose inner diameter is the same as that of the shaft. The sleeve inside diameter, why sleeve he wrote here, I don't know. It is the shaft's diameter is the inside diameter of the hollow cylinder. It can be treated as a hollow cylinder if it is fitted over the ends of the two shafts by means of a jib head key, as shown in figure. You see, it is not necessary it should always be jib headed key only, or it can be even ordinary sunk key also you can put. The power is transmitted from one shaft to the other shaft by means of the key and the sleeve. You see, in this thing, when we see, you see, if this is the machine shaft and it is the motor shaft, it is rotating driver shaft. So when it is rotating, no, because this has power, this power is being transmitted to this key. Okay, and and this key is in this sleeve. So through this key, this sleeve, and comes to this key. So this shaft, if this shaft will rotate when the key rotates, and okay okay, this shaft rotates when this key rotates, and when the sleeve rotates, then only this shaft will rotate. Okay, so these are the things about the muff cup. Okay, when we are designing the sleeve, the usual proportions of the cast iron sleeve coupling are the outside diameter. This is empirical relation. Empirical relation. You take it like this. The outside diameter of the sleeve is 2 times of the diameter plus 13 mm. And the length of the sleeve is 3.5 times of the diameter. These two are the empirical relations, where small d is the diameter of the shaft. Okay, and when we are designing the sleeve, this sleeve design is considered on the basis of a it is considered as a hollow shaft, and we design it. Okay, suppose T is the torque that is being transmitted. Okay, then tau is the permissible shear stress for the material. C may be for coupling, suffix C, because tau S will be for shaft, C for coupling. So permissible shear stress for the material of the sleeve, which is cast iron. And you see, for cast iron, cast iron is very poor in tension or in shear. So see how little this is. Tau C is 14 MPa. Okay, so you should understand that cast iron is very poor, very weak in tension as well as shear. So it has only 14 Newton per millimeter square as the shear strength. So the torque transmitted by a hollow shaft, we know this. T is equal to pi by 16 tau d cube. And if it is a hollow, what happens? T is equal to pi by 16 tau into d to the power 4, or d cube into 1 minus k to the power 4. This equation we are aware when we are designing a hollow shaft, we use this. So from this expression, the induced shear stress in the sleeve may be checked. See, here we are not designing the we are not finding the diameter of the sleeve or the diameter of the shaft using this. We are using this equation only to find out what is the induced shear stress. So if the induced shear stress is less than the given shear stress or the permissible shear stress for that material, then the design is okay. If the induced stress is coming more than the permitted stress, then it is not okay, it fails. Then what you have to do, you have to increase the diameter capital D and then recalculate all the dimensions. So when you are designing muff coupling is designed as hollow shaft. Okay, now till now we have used two equations, one for shaft, one for hollow shaft. Hollow shaft is for the sleeve, and then design for the key. Now, in the design for the key, the length of the coupling key is taken as the coupling's length. Coupling's length is 3.5 D. Okay, this is again empirical relation. L is equal to 3.5. Okay, the coupling key is usually made in two parts. You see, here I have shown you. See, here no, it is shown, everything is shown as entire thing is shown as one key. Sometimes you may be asking, you are saying L is from here to here only, the key is longer. Okay, see, that means what? Key should be at least that much length, and it can extend a little more. Okay, because effectively this is the thing that is in contact with the sleeve, only that will be offering resistance against failure. So when we are calculating the area for failure, we are considering only that portion which is in contact, not that which is outside. This side, that side, it is not helping in any way in transmitting the torque. Whatever is in contact with the sleeve, only that is helping. So if you are saying, if this is 3.5, how is it this also is 3.5? We are not saying this is 3.5. See, the from here to here only is this 0.5. Okay, for inserting, for handling, for dismantling, for convenience sake, you may have take a little larger length. Okay, that is the meaning. Okay, so uh, yeah, when we are designing the key, okay, if the coupling is made of two parts, that if the key is made of two parts, okay, so I told you the key, when you are making in two parts, see, it should not become weak in because of the keyway. See, it is staggered at a 90-degree angle. Okay, 90-degree angle means what? You see, oh, and the side view it is not shown. If this is a side view, one circle, if one is here, the other will be at 90-degree here. As if it is like this, if x, y axis are like this, if one key is here, the other key will be here. See, like otherwise now in the front view, you can see if one key is here like this, another key will be here like this. Okay, that is how it is. Okay, so when we were designing the key, and if it is key is made of two parts, then each key will be half of the hub, that is 3.5 d by 2. Okay, after fixing the length of the key in the shaft, actually what is L now? L is key in the shaft, in each shaft, you can say like that. The induced shearing crushing stresses may be checked. How will you check? We will check by those two equations. Key, we had two equations, one for shearing and one for crushing. Those two equations. You see, these are the two equations. T is equal to L into W is the area of failure and shear into shear stress into D by 2. Okay, this is the equation that we consider when the key is shearing. When it is getting crushed, no, the area is L into D by 2. Okay, and crushing stress into D by 2. You see, this can be used as a CR crushing. But anyway, what stress we take here is normally compressive stress only, sigma C. Okay, so either you call it a CR or simply C, it doesn't matter. You see, what is the difference between compressive stress and crushing stress? Compressive stress is body stress, that means in the whole body that is becoming, whereas crushing stress is only in the contact area. Okay, that is the difference. Okay, and that's all. With this, no, we finish the design of muff coupling. Okay, if you say about the split muff coupling, you see split muff coupling will be like this. You see the upper part, see this is given in a little red color, lower part is given in blue color. These two halves are different and they are fastened together with the help of these studs. What is the difference between a stud and a nut? Yeah, sorry, bolt. Stud and bolt. You know the difference? Actually, in machine drawing, you must have already drawn. I will show you a figure to show the difference. You see here, this is called a bolt. It has a head. No, this is also appears to be a stud only. This is a stud because it is some protruding a little here. This is a stud actually. Stud means both sides threads are there. Then it is a stud. Okay. Then what is here? I'll show you clearly here. Yeah. You see, this is having a head, and this is the shank. This is the threaded portion, and this is the nut. Okay, this is a nut and bolt. Okay, whereas here this is a stud. Okay, and this stud has threads throughout. Sometimes in the middle there may not be threads, like we see here. You see, it can be like this. Okay, or like this. See, both sides, if threads are there, then it is called stud. Otherwise, it is called as bolt. That is the difference. You see, so many times mechanical engineering degree they get, diploma they get, and they don't know these differences. These are the basic things. If somebody asks you what is steel, you should be able to define it. Otherwise, you are not a good mechanical engineer. You only studied to get marks and pass. You only are, mechanical engineer who is able to pass some exams, not to do the work of a mechanical engineer for profession and for earning your daily bread. Okay, so like that, there are studs here. You put insert a stud and put nuts on both sides. Okay, like this it will join. But this side two, that side two, like that. Four studs are needed. So how many nuts will be needed? One, two, three, four. That is here, and here another four, like that. Eight nuts will be needed. Are you able to imagine? See, imagine this. And this is the, you can see this is the key, and it has a taper. This taper is always in the hub. In the shaft it is parallel. Are you seeing? Keyway in the shaft is parallel, keyway in the hub is tapered. Okay, like that. And if you want to talk about this, the muff or sleeve is made of two halves and are bolted together. The halves of the muff are made of cast iron. Cast iron, I told you, because casting is easier. The same things, if you want to produce by fabrication or by machining, it is difficult. It takes time and the skill of the operators and more money. And the material, will be then steel, which will be costly. The shaft ends are made to a butt to each other. Butt means, two types of joints are there: lap joint and butt joint. Butt means just, hitting each other, that is butt. Okay, lap means one above the other, that is lap. Okay, a single key is fitted directly in the keyway of the both the shafts. Okay, single key also, or two two keys individually in two shafts also is there. Nothing, no such hard and fast rule that it should be only one single key. Okay, one half of the muff is fixed from below and the other half is placed from above. I told you what is the advantage of split muff coupling. Split muff coupling advantage is, to make the joint, to make the assembly, there need not be any gap between those two shafts. Sometimes shafts will be very heavy and big. You say, if it is a muff coupling, no, you need space to insert the muff coupling. Whereas in case of split muff coupling, uh, you need not have any space. Both the halves are held together by means of mild steel studs. You see, studs, no, they are bolts. They are not made of cast iron. Cast iron is not good in tension. See, bolts and nuts, bolts, no, they will be experiencing uh, tensile loads, and in the threads, shearing load will be there. So therefore, they cannot withstand. So normally, the material for steels, for the studs and bolts and nuts is all normally mild steel. Okay. The number of bolts may be 2, 4, or 6. Okay, it depends upon how much torque is being transmitted and what is the diameter of the shaft. Depending upon that, 2, 4, 6, 8, like that. Last time what we saw was 8, okay, in that figure. The advantage of this coupling is that the position of the shafts need not be changed for assembling or disassembling of the couplings. Position need not be changed means you need not move the shafts. Okay. Next come to the flanged coupling. You see, design of split muff coupling is not normally asked in our exams. So only the muff coupling they will ask. And also there is another coupling called as half lap coupling. Did you see that? I'll show you a figure now. Yeah, you see here, this is one shaft, this side. This is another shaft, this side. See, they are cut here like this. And like this, you can see here in this figure how inside, when it is broken, you'll see. Otherwise, you can see in this figure. See, in the color they have shown. This is called as half lap muff coupling. Okay. Okay, this half lap muff coupling I showed you only because you should know if somebody asks you what is half lap muff coupling. Now you know simple muff coupling, then split muff coupling, then half lap muff coupling. Okay. Anyway, now next come to, let us see, flanged coupling. Okay, flange coupling. A flange coupling usually applies to a coupling having two separate cast iron flanges. This is again made of cast iron. You see, all the couplings now mostly are made of cast iron because flange, it's not easy to manufacture by machining on the lathe machine and other things. It's not easy. Okay, because there will be a lot of wastage of material. Otherwise you may have to make the flange separately and the hub separately and then weld it. Then now if the weld is weak, again there in the welding it may break. That's why they won't do all that. They use cast iron. Okay, each flange is mounted on the shaft end and keyed to it. Keyed to it means they use key because the shaft and the hubs are there. There will be a key here. The faces are turned up at right angles. Turned up means what? Turning is done on the lathe machine, so that because in the casting when you do, what will happen? You will not get a smooth surface because it is cast in sand casting. So you have to machine and made it exactly right angles to the axis of the shaft. Okay, flanged couplings are different types of flanged couplings. Can be unprotected type flanged coupling or simple flanged coupling. Unprotected type means they are differentiating from the protected type, or simply you can say flanged coupling, protected type flange coupling, and marine type flange coupling, and also bush pin type flexible flange coupling. Okay, that they have not mentioned here. So this is the simple flanged coupling, unprotected type flanged coupling, how it is. Okay, today just to see the figure and other things. I don't know we'll have time for design of this. You see, this is again only the front view is shown, side view is not shown. In the side view, what you will see in from this side, if you are seeing, first you will see a circle for this shaft, you will see another circle for the hub, and then you will see these nuts, this nut here. Only two nuts are there, but in actual practice there could be how many nuts there can be. It can, depending upon the power being transmitted and depending upon the size of the shaft, it can be 3 4 6 8 10 12 like that. Okay, normally even numbers I use, but in small quantity like 3 they will use odd number also, but afterwards even numbers. Okay, and you see even here in the machine drawing, some mistakes. You see, up to the center line it is not cut, so this line should have come up to this place. Are you seeing? This line also should come up to here. This line, these three lines should have come up to here. I'm finding mistakes in the machine drawing. Okay, anyway, you see, nowadays everything, anybody is drawing and using CAD, and without proper proofreading it is being published, and therefore so many mistakes come. Okay, anyway, so the upper half is cut. That's why it is called as half section, and you see one key is here and another key is here. This is the key. So these two are at 90 degrees. 90 degrees you will see in the side view. Okay, then today we will stop here, and we will see the design of this flanged coupling in the next class. Okay, thank you.